All right, you guys, here are the notes for Friday, the 5th of April. We're going to talk about exponential growth, decay, and graphing, and that. So, these are your notes. Okay, your exponential parent function, as we're also aware, is f of x, a, b, x. Now, most of the time, a is going to be 1. Okay? Most of the time, a is going to be 1, but there are going to be times where a is not 1. And I just want to show you that so that when it's not 1, then you understand what that is. Okay. So, when the number b is bigger than 1, the function is an exponential growth. And it is increasing. And the way that you look at that, it says increasing, is you read the graph left to right. And the way that that graph looks is it increases. So it starts low and goes high. When b, so an example would be if you have 2x or 4x, those are increasing. If b is smaller than 1, then the function is an exponential decay. And that is going to look like this. Going from left to right, it starts high and then goes low. So this is a growth. This is your decay. Okay? And it is decreasing. All right? Now we know that an asymptote is a line, and we are only going to be talking about horizontal asymptotes. These in exponentials, they're only horizontal. So I know we've talked about vertical and horizontal. When we've got exponential growth and decay, we're only talking about horizontal asymptotes. And this is a line which the graph approaches. Okay? So basically it gets close to it, but doesn't equal. It never crosses it. All right, so our first example is f of x equals 2x. Let me see if I can get closer a little bit. All right, so here is what I'm going to tell you guys. Please, 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 there is no excuse for you not to plug this into your calculator and be able to graph it. So if I take my calculator, I go to the y equals button, and I punch in the number 2, and then to get the exponent, I'm going to use this button right here underneath the clear button, and then x. That is going to be my function. Graph that, and I'm going to expect, since b is 2, 2 is greater than 1, it should be an increasing, and it is. It's increasing. Then, to graph this, people, I'm going to just tell you, for this purposes of this, we have no horizontal movement, and we're going to talk about that next. But there's no horizontal movement. If there's no horizontal movement, left or right, which would be up here, then we can always use -2, -1, 0, 1, and 2. Now, you should probably always use these two. you should probably always have those as on your table and see what the numbers are for those two numbers. Because you know what the graph looks like now. You know it's going to look like this or do the other way. So if you just know those two numbers, then you should be able to get an idea of what the graph looks like. So then you can go to your table and look. At -2, it's 0.25. That's 1/4. At -1, it's 0.5, which is 1/2. At 0, it's 1. At 1, it's 2. And at 2, it's 4. I'm just looking at my table right here. So then when I graph these, -2, that's just 1/4. -1, 1/2. 0, 1, 1, 2, 2, 4. And I'm going to get this swooping motion. Okay. Now, there is an asymptote at 0 here. Y equals 0. And you guys are advanced enough to know that when we go to the next things and we start talking about transformations, that is going to show you that if you look at this and it's a b to the x plus k, the asymptote is y equals k. There is no k value here. So if there is no number that we're adding, then your asymptote is going to be 0. Okay, this whole section of notes, there's not going to be any k value, so you're always going to have your asymptote at 0. And the reason is there's no number you can plug in that would make this value 0. So there's going to be an asymptote right here, and I'm going to show that with this. It will never, ever, ever cross that highlighted yellow line, that asymptote at 0. Okay? Now, my domain, there's no limitations on x, so it's going to be all real numbers. My range, because these are my x values, there's no limitation on these. The arrow goes this way, it goes on forever. The arrow goes out this way, which that goes on forever. My range, my y values, there is a limitation on. It's never, ever, ever going to touch 0 or go below 0. So y is going to be greater than 0. And it's not greater than or equal to, it's only greater than. And look, notice, your asymptote is your boundary for your range. Yes, always. Okay? My y-intercept, this is where the graph crosses the y-axis. Where is that? That's right here at 0, 1. Okay? And we're not going to worry about end behavior. Okay, let's do another one. Let's do one on the next page. If you need to stop the video so that you can do one on the next page and compare, then do so. So I'm going to look at this and I'm going to say, okay, my b value is 1/2. 1/2 is smaller than 1, so I'm going to expect this to be a decay, which would look like this. Start big and go low. So let's see what happens. I have no horizontal movement. And I have no plus or minus anything. So, and we will get into that in just a little bit in the next video. My asymptote is going to be y equals 0. And I can go ahead and draw that. Get those points for drawing the asymptote. And I also know that my range is going to be y is either going to be greater than or less than 0. It's not a reflection, so I'm going to guess it's going to be greater than. But so I'm going to take my calculator, plug it in. And I'm going to use parentheses, 1 divided by 2, parentheses, to the x power. Graph, what does that look like? And look, I was right. I thought it was going to be a decay, and it is a decay. Perfect. So now I'm going to go to my table. -2 should be 4. -1, 2, 0, 1, 1.5 or 1/2, 2.25 or 1/4. So I'm going to graph those lines. 2, 4, 1, 2, 0, 1, and then 1/2 and 1/4. So it's going like this. It's never ever going to cross that 0 line because that's where my asymptote is. Y equals k. There's no k adding or subtracting. So the y-intercept is where it crosses the y-axis. 0, 1. My range is going to be y is greater than, because it's all up here, my k. Y is going to be greater than k, unless it's a reflection. But in this case, it's going to be y is greater than 0. And my domain, all real numbers. There's no limitations on x, right? Because the only time you have domain restrictions, is when we have x in the denominator or when we have x under a radical. That's not the case in either one of these situations. So we are perfectly fine with domain being all real numbers. These are our x values. All right. So just quickly, this one, do the same thing. We're going to 2/3 is less than 1, so I'm going to predict it's going to be a decay. So stop the video. I'm going to go ahead and stop the video, and then I'm going to work the problem, and I'm just going to show the answer. So if you have not, I would say go ahead and try and work the next 2 problems and then compare the answers. All right, so here is number 4. I've got my table here. It's going to look like this. I plotted the points from my table. My domain is going to be all real numbers. My range is going to be greater than 0. It's up here. It never touches 0, so it's not greater than or equal to. My y-intercept is 0, 1, which is right here. And the asymptote is y equals 0, which is this right here. Okay, so hopefully you got that. Now go ahead and do number 5 and see if this works. This is 5/2 is actually bigger than 1. So I'm going to expect that it's going to be a, oops, the other way. I'm going to expect that it's going to be a growth because this is bigger than 1. So I'm going to expect that it's actually going to increase. All right, so do your table, x, y, -2, -1, 0, 1, 2. Plot your points and figure out what your, this is. Pause. I'm going to pause your video so that then when you turn it back on, you'll be ready for the answer. All right, so when I graphed it, I got my table. I transferred my table over here, and and my graph kind of looks like that. I predicted that it would be increasing. It is increasing. So now I've got my graph and my table done. Y'all, if you do not do anything else, do this. There is no math involved in this. There's no reason you should not be able to do this, people. I care about you too much for you to not be able to do this part. All right. Now the thinking begins. So, my domain, there's no restrictions. It's all real numbers. You should be able to get that answer. My range is going to be y is bigger than 0. 0 is the border, everything above. We don't worry about that. The y-intercept, that's where it crosses the y-axis. Boom. Right there. 0, 1. The asymptote is going to be y equals 0, right? Because there's no number right here. Y equals k, there's nothing there. Y equals 0. Okay? Alright. That's it for the first part of the lesson. Practice those. Take care, guys.